So now actually I am going to explain uh, some configurations you need to do for LPC 1768. So before that, we should know how many ports it has. LPC 1768 has general purpose input outputs is divided into 5 ports. GPIO stands for general purpose input and output. Actually, there are 5 ports are there: port 0, port 1, port 2, port 3, and port 4. Okay, you can configure these ports as input or output. Each port has 32 pins. Out of 32 pins, you can configure only selected pins as input or output, or all the 32 pins as input or output. So in order to configure the pins of port 0 to port 4, any port, any number. Okay, so generally we are going to write a LPC underscore GPION, where N indicates the port number. For example, if N is 0, so then we have to write LPC underscore GPIO 0. So don't confusion with 0 and O. So GP, this is O followed by 0. Okay. GPIO, this is O output. Okay. And followed by number. If it is port 0, write 0. If port 1, write port 1, port 2, port 3, like that you have to write. So general format is this one. LPC means actually low power component, like that. So now we have different registers in LPC 1768. If you want, you can download LPC 1768 user manual. So around 150 page numbers, if you can download. Even it is shared in the lab, Google Classroom. User manual of LPC 1768. Okay. So now if you want to configure any port as input output, you have to use register FIODIR. So FIODIR is a register used to configure pin direction of any particular port. Okay. And this is used to configure the port as input or output. Okay. Any port any port number of that particular port, you can configure as input or output. Okay. After that, there are also some FIO, SIT, SET, FIO clear, FIO pin. We can set particular pin. Okay, set means 1. If I want to set port number 1, fifth pin, then give that particular pin and give FIO set. So that is going to set that particular pin number. Similarly, we can clear also by giving FIO clear. FIO means fast input output. Okay, F stands for fast, IO means input output. We can set or clear. So this is set means set the value 1, clear means 0, or if you want, you can give some value. That value you can give it through some variable. So for when you use some variable, then you can give FIO pin. Okay. Similarly, this pin select registers is going to select a function, because each pin has different functions. So in LPC 1768 IC, there are 100 pins, and each pin they are able to function 4 different functions. Okay, so what is the advantage of doing this one is, instead of having 400 pins, we can have only 100 pins, and not all the functions are always used. So whenever you're using default function as input output, so that is the default functions. If you want alternate functions, then using a mux we can have different functions. So I will explain that with the help of a diagram here. So if you use uh, one pin to have different functions, then which function it is actually going to do is decided by the mux. You can see the diagram here. Okay, for example, this is port number 0, 0th pin. It can function general purpose input output, read 1, so read pin or transmit pin, and serial data. So this pin by default it functions as GPIO. If port 0.0 functions as RD1, then its function is decided by select lines. Pin select 0, first pin, pin select 0, zeroth pin. Zeroth pin and first pin of pin select 0 will decide port 0's zeroth pin function. Okay. When you reset a microcontroller, all the pin select register values will be 0. So by default, all the port pins works as GPIO only. If you want to have alternate functions, then you have to change the value of pin select pins values. Okay. If it is 0, 0, if these two pins are 0, 0, first function GPIO. If it is 0, this is 1. Then this will do the alternate function of RD1. If it is 1, this is 0. Then this will do the alternate function of TXD3. If both are 1, 1, this and this both are 1, 1, then same pin, port 0, 0th pin functions as alternate function of SDA1. So that you can see in the user manual. Okay, 5 ports are there: port 0, port 1, port 2, port 3, port 4. All the ports, okay, and pins functions are decided by pin select registers. So one pin function is decided by 2 pins of pin select registers. Okay, so now we'll go to this is already explained now. And if you want to configure GPIO general purpose input output port number, okay, any port number you can configure as an input or output. Okay, by default all the registers values will be 0 only. So by that means what? So all the ports by default it works as input pins. So in the Viva they will ask, by default all the ports pins acts as input. If you want to configure any port as a output, which particular pin you want to configure as output, that particular pin you have to set as 1 here. So if you give 1, 1 means output, 0 means input. By default all the pin values will be 0, so ports acts as input only. If you want to configure any port as output, you have to give value as 1. So in order to configure input or output direction, so direction will indicate the data is going inwards or outwards. So if it is if you have direction as 0, that means input. If you have direction as 1 means output. Output means from the LPC 1768 the data are going outwards, direction is outwards. And if the configuration is as input, that is 0, then the data are going into the LPC 1768. So inwards means input, if the data are going outwards it is output. So you can set FIO set, fast port output set register, fast input output port set register. Using this you can set any particular pin. Similarly, any particular pin of any port you can clear using FIO clear, fast input output port output clear register. And you can give some pin value by using FIO pin. Example you can see here, FIO pin pin select register function. Pin select registers are 0, 1, 2, 3, 4 different pin select registers are there. So this is shown to explain the function of port 0 only. Only for port 0 I am explaining the function of pin select 0, 0 and pin select 1. So I already told all the registers of ARM Cortex is 32 pin. So even pin select 0 register is also 32 bit. So 0th pin, 31st pin. And in order to decide any function of any particular port pin, each pin can able to perform up to 4 functions. So 2 select lines are required. So port 0.0th pin, port 0, 0th pin is decided by 0 and first pin of pin select register. Similarly, port 0, first pin can perform 4 different functions. So each function is decided by pin number 2 and 3 of pin select register. Similarly, port 0 second pin function is decided by fourth pin and fifth pin of pin select register. Similarly, let us go to the last one. Port 0, 15th pin function is decided by 30 and 31st pin of pin select 0 register. So since one pin is function is decided by two pins of pin select registers, so pin select register 0 decides the function of only port 0 15th pin. So for 16th pin, next register to select. This is pin select 0 and each register is 32 bit only. So 0 to 32 bit is over. So next we have to consider pin select 1 register. It is also 32 bit, 0th pin and 31st pin. So here last one is port 0 15th pin. So next is port 0 16th pin is decided by 0th and first pin of pin select 1. Port 0 17th pin function is decided by pin number 3 and 2 of pin select 1. Similarly, port 0 31st pin function is decided by 30 and 31 pin of pin select 1. Similarly, port 1, okay, port 1 0th pin is decided by, okay, 0th and first pin of pin select 2, like that. You have to check, okay, download LPC 1768 user manual and you can check port 0, port 1 0th pin is the port 1 0th pin function is decided by which pin select register. You can check it out. Okay, so now we'll go to I already shown this example with the help of mux. So if you use this no, instead of having a IC with 400 pins, we can manage the same functions because not all the functions are used all the time. By using this multiplexer we can reduce the number of pins. Okay, so only instead of having 400 pins we can have only 100 pins, and whenever we want some particular function by using select lines we can use that particular functions. Okay, so this is the table extracted from LPC 1768. Okay, you can see here reset value. Okay, this is which pin selector. This is pin selector register 0. Pin select register 0. PN select 0. Pin select 0. Reset values are all are 0, 0, 0, 0, 0, 0, 0. 32 bits are 0, 0. So this is 0th pin, first pin, second pin, third pin, fourth, fifth pin, sixth, seventh pin, eighth, ninth pin, 10th, 11th pin, like that. And port 0.0 is decided by pin select 0, 0th and first pin. If these two pins are 0, 0, so it will do general purpose input output. Okay, it acts as a general purpose input output. That is a default function. Okay, and suppose I want port 0.0 to function as RD1, then these select lines pin number 2 and 3 should be equal to 0 1. Same pin port 0.0 its function is decided by 0th and 1, right? If 0th and 1s are 0 0, it functions as GPIO. If same pin 0 and 1 is actually 0 1, it will perform RD1 function. If 0 and 1 are actually 1 0 0, sorry, 1 0. If this is 1, this is 0, pin number 1 is 1, pin number 0 is 0, then it functions as TXT3, and these two pins are 0th and 1, both are 1 1, then it will do the fourth alternate function SDA1. Similarly, port 0.1, port 0, here you have to write port 0.1, its function is decided by pin select 0.3 and pin select 0.2. Okay, so 2 and 3 of pin select 1 will decide the function of port 0.1 pin. If both are 0 0, it will do general purpose input output. This is a default function because reset value is 0 0. So whenever it is 0 0, you can see all the pins acts as general purpose input output, and these are the first alternate function, second alternate function, third alternate functions. Whenever instead of 0 0, if you change this bit to 1 0 1, that means left side bits are 0 1, it will do the first alternate function. If these two pins are 1 0, it will do the second alternate function. If these two bits are 1 1, it will do the third operation. So now we'll go to the example explaining how you can set any port as input or output. So this is the example. Configure pin number 4 of port 0 as output and set its value as I value. So you have to use the instruction in the embedded C LPC underscore GPIO. Please note down this is O and red color is 0. Okay. So LPC underscore GPIO port number is 0 because I want port 0 fourth pin only. Port 0 fourth pin only I want to configure as output. So GPIO 0 is the port number and you have to write a dash greater than mark. Dash greater than mark and FIODIR fast input output direction, and you have to configure only fourth pin as output, all other as input. So just we'll go back and see FIODIR pin. Okay. Just show the FIODIR because all of you already forgot. So FIODIR was 1 means okay, 1 means output, 0 means input. I want to configure port 0, only fourth pin I want to configure as output. So that's why only fourth pin should be made as 1, all other pins should be 0 only. So go to that assignment because we are checking one by one. I want to configure pin number 4 of port 0 as output. So write 32 pin out of 32 pin. So these are written in hexadecimal. These are in the hexadecimal. So if you write in binary, you can write in 32-bit form. Okay, 0 0 0 0 0. 1 means 0 0 0 1 and 0. And you can check the bit number starts from here. This is 0th bit, first, second, third, and this is 4th bit. So exactly the 4th bit is made as 1. Okay. So now if you give this instruction, it will configure wherever 1 is there. No, that particular pin is configured as output. Here 4th pin is 1. So only 4th bit of port number 4th pin port number 0. 0th port 0 4th pin is high. If you want to configure these 4 bits as high, okay, then give all are 1 1 1 1. Then these 4 bits becomes input port. Okay, input. So that 1 means in output, 0 means input. So now alternate you can do, instead of writing this much, we can also write 1 left shift by 4. So how you can write instead of this, you can write this one means, so 1 left shift by 4. So in ARM, you know that all registers are 32-bit. So write 1 in binary. So in 32-bit format of 1 is this. This is 32-bit format of 1. And you know the left shift operation. This is left shift. So left shift, and this will indicates how many times you have to left shift. How many times you have to left shift. So first time if you left shift, this one will come to this position. Okay, I'm highlighting. If you do second time, it will come to here. If you do left shift by 3 times, every time it will left shift by 1 1 1 time. So 4 time once you do, it will come to this position. Okay, you can see red color. This is possible if you do left shift by 4 times, this will come to here. Okay, so you can write either this format or this format. Both are same. Both are same. Both will configure fourth bit of port 0 as output. Here also port 0 fourth pin as output. So follow this method. This is easy because here if you make some mistake, okay, some students will configure this as 1 2 3 4 and this as 5. So you may get confusion. So that's why which pin you want to configure, just write 1 left shift by the port pin number. So this is actually port number 0, fourth pin is configured as output. This is also does the same thing. This is also same. All are same only. So this method is best. Similarly, this is configured port number 0, fourth pin as output. After that, I want to send a high value to that. So in order to send high value, so you have to use set or clear, you can use, no. So use set, because we have to set here. I want to set it as high. So FIO LPC underscore GPIO 0 FIO set means high value we are sending. Where we are sending? Port 0, fourth pin we are sending high pin. Okay. So this is LPC GPIO 0 FIO DIR. You can also write hexadigit as 10, and after that left side zeros, you can ignore this, and you can also write same thing as like this. Left side zeros you can ignore and you can write like this. Okay, and after that you can set also. This is also correct, and only these two statements also correct. All are these are different, possibly different style you can follow. So best method is this method, this and this. Here we are same thing we are doing here. We are direction we are setting as 1, and it is exactly fourth pin. How it is exactly fourth pin, you can see here. 10 means this. Hexadigits if you expand, you will get exactly at the fourth pin, starting from 0, 1, 2, 3, 4, and same pin we are setting here. So now if you want to configure another question, configure pin number 17th of port 1, port 1 17th pin. So right here LPC underscore GPIO 1, because port number 1, this indicates port number, and we have to configure, we have to use FIO DIR 1 left shoot by 17, because 17th pin I want to configure. Now first you have to set it, then you have to clear the same pin. So LPC underscore GPIO 1 only. Instead of FIO DIR, we are FIO set. We are setting that particular pin, same pin, 1 left shoot by 17. After that LPC GPIO 1, we are clearing same pin, FIO clear same pin. First we are setting, we are configuring port number 117 as output. After that we are setting that value 1 for that particular pin, then we are clearing the same pin. Similarly, if I want to configure two pins at a simultaneously same time, configure pin number 3 and 5 of port 0 and set the output as I. So for this LPC underscore which port I want, port number 0. So LPC underscore GPIO 0, port number is 0, and okay, for this if you want to configure two pins simultaneously, port number 0, 3 pin and 5th pin, so one left shoot by 3, and this is the OR operation. In order to get this pipeline vertical line, click shift slash button. Click slash button is there, no, above the enter pin, above the enter button there is a slash and a vertical line. That if you click shift and that slash button, you will get this type of this will actually do logical OR operation. Again OR with one left shoot by pin. So one left shoot by 3 means exactly third pin, 0 1 2 3, 0 1 2 3 pin becomes high. Similarly one left shoot by fifth pin means this, one left shoot by 3, one left shoot by 5, and do OR operation. So in the OR operation also you know that if any one pin is high, output is high. So 0 OR with 0 0, 0 OR with 0 is 0, 1 OR with 0 is 1, 0 OR with 0 0, 1 0 OR with 1 is 1. So these two pins becomes high. So third pin is also high, fifth pin is also high. That indicates that third and fifth pin of port 0 is configured as output. Then we have to set the same pin. So instead of FIO DIR, LPC underscore GPIO 0, FIO set you have to write. Set pin number 3 and 5. And this if you write using hexadigit number, so 0010 is 2. Okay, 0010 is 2 and 1000 means 8. So you can write this line or you can write this line. Both are same. This is also correct. This is also correct. So here some mistakes are going to happen, because by mistake, if you read wrong numbers, if you write directly this number, it is going to give wrong. So that's why I told you to follow this method. Which pin you want to configure, use one left shift by that pin number. How many pins if you want 2 or 3, do OR operation and write that particular pin. So fourth example, configure first 8 pins of port 0, that is port 0.0 pin to port 0.7 pin as output and set them as I. So LPC underscore GPIO port 0, FIO DIR. Then here actually last 8 pins, no, first 8 pins you have to write 1 1 1 1 1 1. So if more pins are 1 1 1 1, if you group, you'll get F. This is F. This is F. Binary 111 is F. This is also F. So write FIODIR 0x 0000 FF. So here alternate way is what? How to write configure all the pins as output. So alternate configuration is you have to write one left shift by 0, one left shift by 1, one left shift by 2, one left shift by 3, one left shift by 4, one left shift by 6, one left shift by 7, one like that 8 times you have to write. So that be actually lengthy. Instead of that, so write wherever pin numbers you want as output, write 1111 1111. So here actually in this type is better. Instead here you have to write 8 pins, you have to write like this. Even if you have time, you can write like that only. One left shift by 0, one left shift by 1, one left shift by 2, one left shift by up to one left shift by 7. That is also correct. Better here 1111 now. So you can write hexadigit by grouping 4 4. So you'll get FF, or left side zeros you can ignore and directly write 0x 0FF. Okay. And last example is how to configure pins of port 0. Okay. Port 0, 4th pin to 11th pin. Because why I have selected this one only means in LPC 176 supplied by that Vasundhara Technologies board, they used port 0.4 to port 0.11 as they connected to LEDs. So we want to configure port 0.4 pin to port 0.11 pin as output and set them high and low. So LPC GPIO port number 0 dash greater than mark FIO DIR. And here also you can write one left shift by 4, or with one left shift by 5, or with one left shift by 6, or with up to one left shift by 11. So 8 times you have to write that. So instead of that, so write from this is 0th pin, first, second, third. From 4th pin it is 1, 4th, 5th, 6th, 7th, then 8th, 9th, 10th, 11th. So this is from port pin number 4th to 11th as considered as 1111. Now if you group hexadigit, this is get 0, this is also 0 0 0 0, 111 means F, 111 means F, 0 0 0 means 0. So you can write 0x 0 0 0 0 FF 0. So left side zeros you can ignore and directly write FF 0. So this will configure 4th pin to 11th pin as output. Which port? Port number 0. Okay, next same pins we have to set. So using same pin GPIO 0, FIO set, FF0. So this will set port number 0, 4th pin to 11th pin as high. So if you connect any LEDs to that, so because of that set value, the LEDs will start glowing. Okay. After some delay, if you want to clear. So LPIO GPIO 0, LPC GPIO 0, and we are giving clear value. So we are clearing that same pins.